What if I told you that going faster than the speed of light wouldn't just break physics, it would break time itself, not slow it down, not freeze it, reverse it. Meaning, if you could go faster than light, you wouldn't just travel through space, you will travel into the past. We've all heard that nothing can go faster than light, but most people don't really know why. Is it just a limit, like a speed cap in a video game, or is there something deeper going on? Today, we are going to explore what actually happens as we approach the speed of light, and more importantly, what the math says would happen if you somehow went beyond it. And to make it super clear, we are going to use something simple. Imagine a graph. The horizontal axis, the x-axis, is velocity. The vertical axis, the y-axis, is time. So every point on this graph tells you how time behaves depending on your speed. At zero speed, time flows normally. You are just sitting still, nothing weird. But as you start moving faster, something strange happens. As velocity increases, time begins to slow down. This comes from Einstein's theory of relativity. The faster you go, the slower time passes for you, compared to someone at rest. So, on our graph, as velocity increases, moving right on the x-axis, the value of time on the y-axis starts decreasing, not dramatically at first, but the curve begins to bend downward. Now imagine pushing closer and closer to the speed of light. The curve on the graph starts dropping faster. At 50% of the speed of light, small effect. At 90%, significant slowdown. At 99.9%, time is almost frozen. So, what does the graph look like? A curve that gets closer and closer to the x-axis, but never actually touches it. That x-axis represents zero time flow. And here's the key idea. You can approach it, but you can never reach it. The speed of light is like a vertical wall on this graph. As you get closer to it, time slows more and more. Energy required increases dramatically. To actually reach the speed of light, you will need infinite energy, which means physically it's impossible. But let's ignore reality for a moment. Let's do something dangerous. Let's go beyond it. What happens if you cross that line? On our graph, you move past the speed of light, further right on the x-axis, and this is where everything breaks. Because mathematically, the curve doesn't stop, it continues. If you extend the curve beyond the speed of light, something shocking happens. It goes below the x-axis. That means the y value, time, becomes negative. And what does negative time mean? It doesn't mean no time. It means time flowing backwards. If time is negative, events reverse their order. Effects happen before causes. Outcomes happen before actions. Imagine sending a message, and someone receives it before you even press send. That's not just weird, that's a violation of causality. Physics is built on one fundamental rule. Cause comes before effect. If you break that, you break reality itself. This leads to a famous paradoxes, the grandfather paradox, the infinite loops of events, self-contradicting timelines. In simple terms, the universe stops making sense. So why don't we see this happening? Because the universe has a built-in protection system. As you approach the speed of light, your energy requirement grows towards infinity. Acceleration becomes harder and harder. So before you ever reach that barrier, you are stopped, not by a wall, but by the laws of physics themselves. Interestingly, the equations don't completely forbid faster than light motion. They just make it unreachable for anything with mass. There are hypothetical ideas, particles that always move faster than light, shortcuts through spacetime, distortion of space itself, but none of these have ever been observed. So here's the real takeaway. The speed of light isn't just a speed limit, it's a boundary between two different kinds of reality. On one side, time flows forward, cause leads to effect. On the other side, time will flow backward, reality becomes inconsistent. So when you hear that nothing can go faster than light, it's not just about speed, it's about protecting the structure of time itself. Because if you could cross that line, you wouldn't just be moving faster, you would be moving into the past. And maybe the most fascinating part is this. The universe doesn't just allow this idea, it shows it to us mathematically, and then makes sure we can never reach it. So, I wish you enjoyed. this kind of deep dive into the space, time and the universe. Bye!